All right, here we are streaming for the first time. Welcome to the stream. So today I'm going to be building a starship HUD. Now what that means is I play a game called Elite Dangerous, as most of you watching this probably know, because you probably know me. But we've got an Elite Dangerous. You fly around in starships, right? That's pretty much it. And this is the gist of what your HUD looks like when you're looking straight forward. You've got these things telling you about your guns and your different pieces of the ship. That's not quite the part that we're going for. What we want is this. So when you look to your left or right, you get to see these nice interfaces that have, you know, your navigation and such. They show on the other side, they show like your ship modules and different stuff like that. That's more what we're going for. I want to be able to pop open my browser and look in and see this cool 3D version of a couple of interfaces that I can then interact with. So I started working on this yesterday and I got some progress. So this is rendered with Three.js using the CSS 3D renderer. And what it's doing is taking and creating a couple of new elements and sticking them in the page, and then using CSS 3D transforms to place them where we want. And so I've got these fancy sliders up here. If I hide the background image, it's a little easier to see. So we'll hide that. It should update here in a sec. There we go. So we've got our field of view, so that'll actually change how wide our viewing angle is. We'll set that back to normal. We've got our perspective, so we can back out basically from our interfaces. Our offset is just how far they are from the center. They actually start off just right in the middle with no rotation. But then our rotation. So these sliders I threw in just so that we could sort of play with it and see, you know, how does it make sense, what actually looks like it's where it's supposed to be in the interface. So anyways, I started this because I haven't done a Three.js project in a while. I haven't actually worked with Three.js in a while, so I wanted to get a handle on how things are going to go with that. But for the most part, I'm going to be doing this just, you know, with research while we're working on the project. So I'm going to pop on over here. I'm going to do all this work in Codepen. So that should be relatively simple. If you're not familiar with Codepen, you should check it out. It's codepen.io. It's a really great alternative to like JS Fiddle and JS Bin, these different websites where you can go in and put in your script and see it run and see what happens. But one of my favorite things in Codepen is that you've got the opportunity to change your code to be run through these precompilers before it's put into your preview. So we're going to use Sass and we're going to use Babel. So we've got all of our fancy ES6 stuff working. We're also going to use this quick add feature and add in Three.js. And then I'm going to pop on over here because we also need the CSS 3D renderer, which we don't actually need the point of lock controls, but the 3D renderer, which we're going to borrow just from the Three.js website for now. We're going to hot link it because, you know, sometimes you just got to be a bad person. We're going to call this Starship HUD. And then CSS, we're good to go. We're not going to use any extra libraries for that. We're going to use prefix free and the Meyer web reset. Yeah, and that should be it there. HTML, we're going to use plain HTML. I hate using Haml or Pug or anything like that. You know, Jade. I like my good plain HTML, so we're going to work with that. All right. So first things first, we're going to stick an element in the page. We're just going to create a div. Yes, I know I'm not being semantic, and I gripe at everybody all the time about being semantic, so sorry. But for now, I don't know that there's a better semantic element for this, so we're just going to use a div. This is our HUD. That's where it's going to live. Now we're going to kick it off. I'm going to do this, like I said, with some fancy ES6, ES7 stuff. So we're going to start off by making a class of starship HUD. Yeah, that's pretty much it. We'll have a constructor, because we always have a constructor. And then, yeah, so I'm going to put in some comment headers. Let's see. I'm going to do this in brackets real quick so I can count the number of things I've got in the line. I like to do, yeah, that's about it. Paste those in there, get rid of a couple. I like to do this just because it makes it easier to read when you're looking through your source later. But these are our public methods. It's just sort of a table of contents for what's in your class. And then we will have some getters. I don't think we'll need any setters. At least I didn't use any yesterday. And then we'll also have our private methods. And just a personal preference, I always separate these guys by 5 lines of white space. Again, it's a nice visual break to complement the comment header. Yeah, okay, so public methods. Now, if you've never used Three.js before, Three.js adds a, actually we'll just do this down here. It adds a global to the window called 3. So if we check our console, it should log this out for us maybe. Save and rerun it, see what happens. Or if we check the browser console. Yeah, there we go. Logged out an object. There we go, 3. So it's got all this fancy stuff on it. The things that we're gonna need most immediately, I'm gonna put into getters. So we're gonna do a get renderer. It's going to return renderer. Now this is not actually what we're going to do. We're going to say, or we're going to do some fancy stuff in the getter to make sure that we're not creating a new renderer every time we try to get it, and that we're not doing anything unnecessary basically. So instead of just returning a new 3 renderer, we're going to return this _underscore renderer is how I like to do it. And if that is falsy, then we'll return this _underscore renderer equals. All right, so because assignments are expressive, this will assign new 3.renderer to this _underscore renderer, and then the next time we use the getter, we'll just get back the same renderer because this won't be falsy anymore. Now I think we need to do some other stuff to our renderer before we actually send it back, but this is what we're going to work with for now. Okay, so we've got our renderer. We're also going to need a camera. So the renderer is basically the engine behind Three.js that's going to take all of the it's going to take all of the input that we give it, the camera, the 3D objects, things like that, and it's going to determine where they get placed in the scene, right? So we're going to call render from the renderer on every frame using request animation frame. We'll get to that here in just a minute, but the camera, of course, is the camera. So you can set all kinds of crazy things on the camera, like what's the film gauge and what's the the distance from the film, and what's the field of view, things like that. We're going to use a perspective camera. I'll be honest, I've not actually used any other cameras from 3 before, so this is the one that we're going to work with, but I know that there are some other ones. There's like an orthographic camera and different things, and maybe I'll use those in another stream one day, but not today. The last thing we're going to need is a scene. if you're curious about why I'm putting these in weird places, I'm just doing it in alphabetical order. That's how I like to build my classes. So we've got a scene, 3.scene, and this is, you can have multiple scenes for a single renderer. Honestly, I'm not sure what the value of that is. So if you know, feel free to throw it in chat and let me know, or post a comment. But in general, I have no idea. I'll just be totally honest about that. All right, so we need a camera, a renderer, and a scene. So we're actually going to return CSS3D renderer, which we got from importing CSS3D renderer. It also gets attached to the 3 object. If you're not sure what I'm talking about with these things in the pen settings on Codepen, these essentially get added to the bottom of the body tag in your display here as just script tags, so that they get imported, and they are done in order. So if I put CSS 3D renderer first, it would actually throw an error because 3 doesn't exist yet. So anyways, I'm gonna save that. Okay, so we're gonna go ahead and just stub out some other methods that I know we're going to use, like bind events. And this is a pretty standard architecture that I use. So 2, 3, 4, 5, where I have a global bind events function, and in there I bind all of the events that need to exist for the lifetime of this class. So we're going to do like window.add event listener resize, and then we'll pass a function into there. We're also going to need, actually I think that's all we're going to bother with right now. And then we're going to stub out the resize method, which is going to be a public method. Let's just stub. So for add event listener, we'll just do this dot resize. And one other thing is, because we're using an event listener, this dot resize is not necessarily going to have the context of the class. So down here in our constructor, what I like to do is say this dot resize equals this dot resize dot bind this. And what that does is basically resets the resize method on the class so that it always, no matter where it's called from, has the context of the class. And I do that for all of the methods that I have that need to be bound, that are going to be run outside of our class's context, like this. Okay, so resize, and then we're going to need a render function. I think there's plenty more to be added, but that's probably good for now. Let's go ahead and create some things. So I'm going to reference the pen that I built yesterday just to see what all I'm missing. So yeah, you see I did a bunch of bind events in this one. Most of these are just for these controls over here. So, when those range sliders change, we're going to update the positions and rotations and such for all of our 3D objects. Now our generate camera, I'm just going to copy this over here, and then I'm going to reference it real quick. So in camera, we're going to put all that in there, and then I'm going to comment it out just for now. So this reminds me we need an FOV getter, FOV, which is field of view, if you're not familiar. Which, again, over here, it's basically like if you can see 180 degrees, that means you can see your field of view is 180. Then that means you can see absolutely everything from directly to your left to directly to your right, and everything in front of you. If you have 75 degrees, then it's like 32.5 degrees from straight ahead of your face. Either direction is how far you can see. Casey, I'm gonna I'm gonna smack you if you ask such an awful question. That's mean and rude. But also, I love you. Okay. Let's see. I'm gonna pop over here and say root. Cool. Okay. I mean, let's be real. The only real difference between Java and JavaScript is that Java has static typing, right? I mean, that's the only thing. So, okay, our camera over here, we do this generate camera stuff. I have a bunch of things for generating these panels, which we're not to yet. Generating our renderer, we're gonna copy that over. Comment it out. Again, I'm commenting these things out just so that I have them for reference when we go beyond just stubbing them. We also need a width and a height. Let's say get width. What else? There's something I just thought of that element. So we're gonna need get element, and this I'm gonna go ahead and write out. We will return this dot underscore el or equals document query selector. We're just gonna hard code HUD in here, and so that will guarantee that our element is that HUD div that we created earlier. All right, I'll pop over here. Okay, so our element is that guy, and then we can go ahead and fill out our height and width getters. Height is going to be return this dot element dot offset height, and our width is going to be the same thing but width. Cool. So we've got those guys for now. Field of view, I think I just hard coded in here somewhere. Oh yeah, because it's using the slider. So we're just gonna fake it for now. What is the value on that guy? I'm actually gonna refresh this. Don't reload, or no, reload. Crap. All right, so document dot query selector hash FOV. That's V. That's going to select our slider dot value. It's going to tell us what our default is, which is 40. I could have also just looked at the HTML, but that's way too simple. So we're just going to return 40. Okay, so that's our field of view. All right, let's work on setting up our camera. So field of view is this .fov. Okay, so when we create a perspective camera, we're gonna, oh, I remember why I did it that way. Okay, so I was trying to recall why in the original version I did starship HUD, hide this, as, or why I did generate camera as a function rather than a getter. And the reason for that is so that we didn't have to do a bunch of weird stuff in our camera generator. So what we're going to do here is just check to see if camera exists. If this.camera, we're going to return the camera. Otherwise, we'll do the rest of the stuff, and then it'll be magical. Okay. Otherwise, we're going to say let camera, so we're block scoped, equal new perspective camera, which takes field of view and then aspect ratio and then near and far. So field of view we already talked about, so that's just this dot FOV. The aspect ratio is going to be this dot width divided by this dot height to come up with basically a decimal version of what our aspect ratio is. And then near is the absolute closest that you can get. It's basically what's the smallest unit of measurement in your scene or for your camera. So here we're just going to do 1 and then 10,000, which basically is some completely arbitrary amount of units. Okay, so where's the camera? So we don't need that anymore. Okay, so we check to see if the camera exists. If not, we'll create it. Once we have created it, we're going to set its position. Position equals, I think, we hard coded it over here. The default value for it is 1535, which is a value I came up with by literally just screwing with the sliders until I was happy. So we're going to set it to 1535. Oh, that's the Z. If you're not familiar with three-dimensional axes in the browser, basically X is left to right, or right to left. Y is up and down, and then Z is like directly through your screen. So from your face to the other side of your screen is the Z axis. We are setting the camera's Z axis or Z position because it starts out at the very center of the scene, and we want to back it out from that so that it fits. Basically, we can see everything that we want to be able to see in the scene. Otherwise, we're going to have to set stuff away from the center so that the camera can see it, which is a little awkward programming-wise. So that should do it for setting up our camera. All right, next up we'll do our renderer, and then we'll do the scene. So let's see, our renderer can just be 3.css3d renderer. I was trying to get anti-aliasing to work, but that's not actually a thing with the CSS3D renderer, because of course it's all CSS. So I was trying to fiddle with it yesterday and figure out a way to get anti-aliasing to work in 3D in Chrome, which seems to be the only place it's messed up, which is super weird. I haven't found a solution yet. So if we have time, we may mess with that today. All right, so we're gonna say let render equal new CSS3D renderer. Then we're gonna set its, so when you create renderer, it generates its own DOM element. We are gonna set the position on that to absolute, because it doesn't have classes or anything. We could also just do classlist.add and then control it with CSS, which we may go back and do at some point. But right now, I'm just gonna do it the way that I did yesterday because I know that works. Also, if you have any questions, there's not a whole lot of people watching, but if you have any questions, feel free to toss them into the chat, the YouTube live chat on the right. That's what I'm actually watching on my other screen here. Or you could tweet me, mention me. I should get notification over here, but I guess we'll see. All right, so we've got that. And then we need to do the same thing that we did with the camera. So we're gonna check if this.renderer is a thing yet, and if it is, we'll just return that. And if not, then we'll create the new one and assign it while we return it. Okay. Great, so there's that. Now we'll set up our scene. There's a bunch of stuff in the JavaScript over here that we need to grab to do that. Got a generate scene function in here somewhere. Oh, no, there's literally nothing special we need to do that for that, just return a scene. So great, that's nice and easy. Okay, I think we're ready to start rendering some stuff. Let's see, what else do I have in the constructor here? I think we do bind events. Oh, I'm in the private methods, public methods. Yeah, we bind our render and our resize. So I'm gonna go ahead and do that with the render function. Oops. Cool. And then I think we initialize, yeah. So initialize is probably completely unnecessary. It just helps to abstract these things from the constructor, which again is probably completely unnecessary unless we wanted to have an uninitialize or deinitialize method that did things like, you know, remove the stuff from the page and remove things from the scene or whatever. So I'm gonna skip abstracting it for now, and we'll just yeah, this.resize and this.render and this.bind events. Okay. So this dot bind events, again, this is so that when the class gets built, it'll bind all of the events that need to exist globally. Well, not necessarily globally, but all of the events that need to exist over the lifetime of the class. So in this case, it's just resizing. And then we're going to do this dot resize so that we force a resize, which I'll get to here and why we need to do that here in just a second. And then we'll do this dot render, which will kick off basically the rendering and the animation. So if we look at our render, yeah, what we need to do in render is say this dot render dot render, I think, right? Yeah, and we pass it the scene, and we pass it the camera. And the really nice thing here is that we've done our renderer and our scene and our camera and all these things as getters. So we don't have to have separate methods to initialize them, because as soon as they're called for the first time, that's when they get initialized. Elite Warrior, what information will the HUD display? That's a great question. So I showed off a picture earlier of the Elite Dangerous Starship HUDs, which look a lot like this. They show off things like different locations you can fly to, and you know, what sort of modules you've got installed on your ship, stuff like that. We are probably going to just shove some junk in there for now. But what I'm thinking is that today we'll build like the framework for our displays. So basically we'll have a couple of boxes, we'll put some text in them, things like that. And then in the next stream, which might be this week or might be later, I don't know yet, I'm actually going to go in and figure out how to replace what's in those boxes with React content, so we can have a React application running inside of our 3D frames, HUDs, whatever. Yeah, so I hope that answered the question. Yeah, cool. All right, so we do this .render, we pass in scene and camera, and then we're going to do request animation frame. If you're not familiar with request animation frame, it's very similar to set timeout or set interval. It's closer to set interval, where you call it and you pass in a function that you want to run. Thanks, Casey. I miss you. I'll talk to you later. So request animation frame. So we're going to run this .render. Now, again, render is bound to the context. So request animation frame is going to run this method outside of context, but render will still have context because it's been bound. And then essentially this is going to kick it off so that we're running this method 60 frames per second. So nice and quick, or at generally 60 frames per second. So we run render once, which is going to kick it off, and it's just going to go forever. Now our resize method is going to set this .camera FOV, I think. or aspect ratio. Oh, I don't remember. Let's see. Resize aspect. Okay, yeah. So we need to update the aspect ratio equals this dot width divided by this dot height. And now you may have noticed when I made our height methods earlier, we don't store the height like we do the rest of this, right? We don't cache it. That's because when the size of our element changes, we want to be able to resize and get the new height and the new width so that we can generate a proper aspect ratio. So this dot camera dot aspect equals this dot width divided by this dot height is going to be up to date with what the element's actual width and height are. And then after that, I think we need to do this dot camera dot update projection matrix. And I'll be completely honest, I don't know what the terminology here really means. Projection matrix means something, but essentially what we're doing is the camera is set up with the aspect ratio that we give it when we first create it. When we change the aspect ratio, it just kind of ignores that until we force update the projection matrix, causing the camera to reset its basic setting. So its aspect ratio or its field of view or whatever, things like that. Yeah, so we'll update the projection matrix. I think that's it. And then we need to do a set size. The puppy is upset that there are cars on the road. So we'll need to reset the size on the renderer. So we'll say this dot renderer dot set size, which is a nice convenient method, to this dot width and this dot height. Right, I think that's it. Yeah, this dot width and this dot height. And so that will, so updating the camera aspect ratio and projection matrix will cause the camera to be displaying everything at the right size, but the renderer will still be too small. So we have to set size and get that to get bigger. Let's see. So we've got all this stuff. And then if we go ahead and add some logs in here, just for funsies, say rendering, and then resizing. Cool, got some logs. Now if we check our console, and then down here at the very bottom, we'll clear it just so we don't have that ugly warning message. Okay, we will new starship, if we spell it right, HUD. And it should kick off. There we go. We're rendering. And now if we change the size, we should see some resizing logs pop up in there. Yeah. I don't know if that is moving too fast for the stream to catch it, but it did work, I promise. So we'll clear that out. We'll stop our starship HUD and get rid of those logs. Up here. Okay, cool. So this is the framework of a Three.js CSS 3D application. Like you just, you create your renderer, your scene, and your camera, you jam them all together, give them the right parameters, and then you have a Three.js application that you can start putting magical, awesome 3D-ness into. So what we're going to do next is create an actual panel that we can then see in our 3D scene. So let's do that. I believe, actually, I'm going to try doing this from memory first. So we're going to do generate panel, and then let element equal document dot create element. We'll just create a div here. We're going to say element.classlist.add. If you're not familiar with this classlist.add syntax, it's awesome. It's basically the jQuery.add class or jQuery.remove class syntax, but in native JavaScript, which is pretty sweet. Okay, so we'll add the class of panel because we know we're always exporting a panel, and then we're going to return new CSS. No, we need 3.css3d object. Now, if we weren't using the CSS 3D renderer, then we would just return new 3.object, I think, or 3D object or something along those lines. But we're going to do new CSS 3D object, and we're going to pass in the element. And I think that's all we need to do there. Yeah, CSS 3D object, we add, and then we return it. Cool. So that's generate panel. Now, I want to be able to do left and right panels differently. So how did I do that over here? I created separate methods, but I think we could dry this up because both methods do essentially the same thing, just in a slightly different way. Generate left panels where I was doing all the stuff that is actually interesting. So I'm going to copy this over, and again, we will comment it out. I'm just going to stick it at the top here. Doop doop doop. Cool. All right, so we generate a panel. That's great. Original panel. Okay, so this stuff right here was all intended to grab the. Basically, I created the panel elements in the page before I created the 3D elements. So there was just HTML, and then I sort of stole the inner HTML of those elements and jammed them into my CSS 3D panels. That is not what I want to be doing. Eventually, I want it to be React, so I want to be able to render a React application inside of each of these panels. So I'm gonna kind of ignore this stuff for the moment, but what we need to do is set our position and our rotation on each panel. So I'm gonna change this around a little bit. We're gonna do a new 3 CSS object up here immediately around the element. I'll just return an element. I think that's all we need to do. And then we're gonna do, we're actually gonna call this panel. Yeah, okay. So we'll call it panel, and then we're gonna say panel.right. There we go. .element.class.add, I believe. Yeah, right. Because the 3.css object exposes its DOM element through the .element property. So we've got that, and then we need to set position and a rotation. Now, I think what we're gonna do is just take a side parameter in this generate panel, and then we'll say, we'll just do a switch statement, because why not? Side case left, and then case right. Okay. Let's see. Just say. All right. So panel offset and panel rotation. All right. Those were coming from sliders as well. So let's just get the values of those. So our default offset was 803. We'll just do 800 because I like round numbers. And then the rotation is -41, so we'll do -40. Yeah, so that's gonna be weird because we're doing negatives to make it a positive, but it's gonna be okay. Okay, so the reason that we need to do this is because, again, we're doing 3D stuff. So our position for the left one is going to be negative on the x-axis. The position for the right one is going to be positive on the right axis. And then the left one is going to have a negative rotation, or a positive rotation on the y-axis. And the right one is going to have a negative rotation on the y-axis. So let's just use a hammer for right now. And just stick it all in there. You know, it's really not any more dry, but we're going to go with it for now. So right is going to be positive, and a negative rotation. And then this one should be a positive rotation and a negative position, I think. So, let's see. No, what am I doing? Okay, back to the JavaScript over here. So next up, we want to, we want to add those to the scene. So we're going to come down here to our constructor. We bound our events. We're just before we do a resize and a render, we're going to say this dot scene dot add. This is just how you add objects to a scene in Three.js. So we'll add this dot underscore generate panel left, and then this dot generate panel right. There we go. All right. So let's do some CSS now. Let's say panel is going to get a border of 10 pixels. Whoops. 10 pixels, solid and red. Let's see if anything happens. I don't think anything's going to happen. I think it's broken. And the reason for that is, oh man, got a lot of renders in here. Let's clear that out. All right, the reason for that, is because our elements are all too small. There's no content in the body, basically. So let's do some bootstrap CSS. We'll say HTML and body. This again is some pretty standard stuff that I put in, where height is 100 VH. If you haven't used VH before, that's viewport height. So in the browser, it's going to be from the top to the bottom of the viewport, and then VW would be viewport width, so same thing, but horizontally. In an iframe, which is what this is, we're going to get just from the top to the bottom of the iframe, and then horizontally for the width. So we'll do that here as well. All right, so there's HTML and a body. And I think I can actually leave the HTML off this because it should stretch over the body. Yeah. So that is 597 by 372, and our iframe is 597 by 372. Perfect. So that's doing exactly what I expected to, but we still can't see anything here. And I think that that is because now our HUD has no size. So let's fix that as well. HUD. It's going to be the same height and width, I think. Yeah, okay, so that has its size, but we're still not seeing anything. So let's see what's going wrong. All right, in our render, well, we add this dot generate panel left and this dot generate panel right. Okay, let's throw in some logs. I avoid using debuggers in Codepen just because things usually act really weird when I do. So anyways, we'll console log rendering. Make sure that that's actually doing what I expected. Oh, yeah, well, remember when I turned this off earlier? That's why nothing's working. It may still not work. There may still be things broken. Okay, well, we've got a renderer popping out, so there's at least that. What this is saying is 3.css renderer is the renderer that we're using, and we're on Three.js version 84. They don't use semver, which is bothersome, but they also only export global components. So there's, you know, I could gripe about things all day long, but okay. So we have let's just look at it from the beginning. In our constructor, we bind our render and our resize, so those are always bound to the context. We set our events, or bind our events. We add our panels to the scene. We resize the scene, the renderer and the camera, and then we render. But it didn't look to me like it was actually rendering, because we're not getting the renderer. Oh, that's because I got rid of the console log. Let's see, we should get that now. Okay, we're rendering, and so that's great. Let's see if it still works. If we put it after there, yep, still working, no problem. How about resize? If we do this, yeah, resizing works. Okay, great, so that's not the issue. Let's check our panel generation, because maybe there's something weird up there. First, I'm going to delete all this junk that we don't need. All right, let's see. We get, yeah, we generate 2 panels. All right, so I'm gonna use string interpolation syntax. If you've not seen this, it's an ES6 thing where you use backticks instead of single quotes or double quotes, and then you can interpolate a string. So we'll toss $side in there. All right, generating a panel for the left, generating a panel for the right. All right, so that seems like it's working, but let's get even more granular here. Come down to see what the panel actually looks like as an object before it gets returned. Okay, great. So we've got CSS3 object. There's no name, which is fine. We have an element there, which has not been added to the DOM. Okay, well that's a hint for us, because the way that the CSS 3D renderer works is it takes those elements and it will add them to the DOM. So we should see 2 divs with the panel class inside our HUD element here, but we don't. So let's check this guy from yesterday and see if we can find anything in here, any code smells, and give us an indication on why this might be broken. So these we don't care about. Let's move on to generate camera. Field of view, aspect ratio, near far, and set perspective. That all seems right. Let's just make sure our perspective is actually what we want in our camera down here. Camera. All right, return this dot camera. If it's falsy, then we're going to skip on down to this stuff. Let's make sure that we actually do that. Yeah, okay, so we do create a camera, and it all looks fine. And then, what did I actually, oh yeah, camera. Let's see what camera looks like as an object. Make sure that that is not like undefined or anything weird. No, FA, I don't know why that's called FA, but either way, we've got a type of perspective camera, far, near, that all looks fine. There's our matrix. Yeah, so it doesn't look like there's any issues with our camera. How about our scene? No, we just create a new scene. That's all we need to do. Do we do anything? Start generate scene, yeah. Okay, well, we were at a camera. Let's go down to our panels. We set our offset and our rotation, and then we return it. Okay, well, that's fine. And our generate renderer. I remember this, if I didn't have this in here, then it would break. So let's just try commenting that out real quick and see if that's still the case. Oh no, it's totally not broken. Cool. All right, how about my CSS? Did I do anything weird in CSS to get it to work? I did a flexbox setup so that I could get these guys to fit in there and this to just grow and take up the rest of the space. pip, that's the picture-in-picture. I did a thing, so there was a video down here. HUD, and then panel. And I gave my panels a height and a width, but I don't think that's... Well, that's not the issue because they're not even being rendered to the page. If anybody has any suggestions, feel free to throw them in chat. All right, generate renderer, generate right panel, generate scene, just new 3.scene. Constructor, we do that stuff. Oh, yeah, I should probably, actually append it to the page. So let's do that in the constructor. That's gonna fix everything. Or maybe not. Got an issue. This dot renderer dot element. Hey! So I don't know if you can see them on the stream, but we've got two tiny little boxes here. Tiny little red boxes. Those are our panels, which is super cool. So let's give those panels some size. What I did was, as you saw in the other one, is I actually gave it a height of 100 VH and a width of 100 VW, and that way our panels are as big as our actual screen size. And my theory with that was that later we can come, hey, there we go. We've got some rotation issues, but we can fix that. But yeah, my theory is that we can come back later, and if we want, say, you can come over here and click on one of the panels to focus it in. We can pull it in and take up the whole screen because it's full viewport width. So let's go on back and fix that rotation real fast. I just got those backwards. So yeah, that's going to be negative, and that's going to be positive. That should put things, yeah, there we go. If we adjust our perspective in the camera, we can see a little better what all's actually going on here. So we'll just crank this up to 2,000, take us a little bit further out. Okay, we'll crank it up to 5,000. All right, we'll take it down to 4,000. See, this is why I did the sliders. It was way easier to adjust as I was messing with stuff. 3,000 was too close, right? Nah, 3,000 is fine. Okay. So you can see we've got our two panels. They're offset by a bit so that essentially you're looking down the center here, and you've got a panel on the left and you've got a panel on the right. Sound familiar? Boop. This is your left panel. You have stuff in the middle. You have a right panel as well. Cool. So we've got our panels. That's great. And these are just DOM elements. Again, this renderer is using CSS 3D transforms. So we can go in and select this guy and see the element itself. And you can see how it's doing things. It's doing a CSS 3D transform. It's doing the translation, which is basically our offset position that we're passing in is causing this to go, negative 50% to the left. If we look at the other one, it's also negative 50%. So no, I'm totally wrong. I translate negative 50%, negative 50%. So that should be up, down, left, right. But it doesn't see. Oh, never mind. It's saying translate negative 50, negative 50, so that it sets it at the very middle. And then it's doing a matrix 3D transform, passing in this crazy matrix that it's generating to tell it where it should actually exist and how it should skew and things like that. So the matrix 3D transform is pretty sweet if you're crazy enough to get in and do the math. You can do some really cool stuff with it. And it's just a single transform function that you pass in rather than doing like a million different transforms. Okay, so we've got this guy. Let's put some stuff in it for now. Like I said, for now. So we're just going to do this in... and you can kind of see as we squeeze the box, if it gets wider, you can see that the panels get wider. When I get skinnier, the panels get skinnier. Again, that's because we did CSS 100 VH and 100 VW so that it fits our viewport size. So if this guy was right up against the viewport, it would just take up the whole thing. All right. Now let's put some junk in there. So we've got our left and our right. Now, I am feeling now like I am gonna put a bunch of crap in here, and that's gonna be just a pain in the butt. So I'm gonna go back to doing it the way that I was doing it yesterday, where we also have a generate right panel method and then a generate left panel method. Again, if you weren't here at the very beginning, which a couple people have joined us, then if you're wondering why I keep putting my methods in like weird places, I'm like, here, let's put this one down underneath and let's put this one up above and blah, blah, blah. I just like to do it in alphabetical order. So L, P, R, whatever. Okay, grab this stuff and abstract it to here. Yeah, and so now you'll see everything jumps back to the middle because it's not actually getting anything set up. So we can steal these for the left panel. Boop. Okay, and then do that. Okay, great. We're gonna say let panel equal this dot generate panel. We'll do the same thing down here. And then I am gonna abstract these out again, these values. So we'll do this dot panel offset is 800. We'll come down to the getters and create one for that. Get panel offset. Okay, then we'll just return 800. We'll get panel rotation is the other one. And we'll just return the 40. And if we come back up here, yeah, we'll change these guys over to this dot panel rotation. Cool, so there's that. And for both of these, we're just gonna return the panel after we're done. Dump that stuff for now. And great. So we'll come back down here, and instead of doing generate panel and passing in the sides, we'll just do left and then right. Cool, and we've got everything back in position just the way it's supposed to be. Now, let's throw some junk into one of these panels. I'm gonna do the left panel to start off. So, all right, what do we want to throw in there? Any suggestions? If you have a suggestion, throw it into chat. I'm actually gonna take a short break. I'll be back in like 2 minutes. All right, I am back. So, where were we? We were about to put stuff into a panel. Let's actually make this look like something. Okay, so what do we want to put in there? I got no suggestions, so I'm just gonna make some stuff up. I think we'll put a list in there. Let's start with that, I guess. Let's see. We're gonna abstract this as well. Up here, generate left panel content. And then what we can do is create some elements and pass them back so that the generate left panel function can actually inject them into the element. Alternatively, we could actually just receive the element here. And so let's create a list. Document.create element li. Actually, so here's the thing. I could put a bunch of static HTML in here, but at the beginning of the stream, and in the stream title, I think even, I mentioned React. And here's what I'm thinking. Like I said, I could put a bunch of static HTML in here, or we can go ahead and figure out this React thing. I think we're going to go that route. We're already about an hour into the stream. Why not go the rest of the way? So here is what I'm going to do. I'm going to empty that out. And then I'm going to save this in JS. Now, let me be clear, I have not done this part at all before, so it's probably going to be a little wandering and like trying to figure out what the hell I'm doing. But we'll get there, and we'll get there together. All right, so we've got React and React DOM. Let's see, are those just globally accessible? Is that how that works? Okay, yeah, so that's a thing. Okay. Great. So we can, let's create a new class. Class, we'll just say left panel extends react.component. Now, if you're not familiar with React, this might be a little harder to follow along with. I would definitely recommend getting a grasp on that before you dig into the React stuff, but we're gonna give it a shot right now. So our render method is gonna return just an element. We'll just say an H1 that says hello world, because this is programming. We should always do a hello world in programming, right? Okay, so we've got a left panel that extends a React component. Great. Let's come down here and say React DOM dot I don't remember the syntax. Let's look some stuff up. React. I just want React. Just React. There we go. All right, we're gonna go to the docs, and there's, yep, so there's our hello world. Okay, React DOM.render, that's what we want. So, not that, that. React DOM.render. I think we pass in the element, and then it'll be like left panel. Right, does that sound right? Oh, no, backwards. I need to do it the other way. So we're going to say left panel and then element. So do we get a hello world? We don't. All right, what's our console say? Nothing useful. Let's check our browser console. React is not defined. Okay, so where did I mess that up? So we've got React DOM. React is not defined. Where's that coming from, I wonder? Well, we've got object getting logged out somewhere. So where are we doing logging? Console.log. Is that in here anywhere? No, so that's not actually from us. That's coming from somewhere else, which is extra weird. All right, let's see. React DOM, is that? Yeah, that's an object that has all the things. 5.4.2, render. ETN, I don't know what the N is, but V for virtual DOM, then render subtree into container. So that's all right. That's what I would expect it to be. Oh, if I actually use this method, it might help a little. Christ, I can be such a dork sometimes. Panel, and then we'll do this dot. All right, now let's see if we get a header in there. Okay, minified React error 37. Visit this link to see the error. Sweet. Register component. Target container is not a DOM element. Oh, okay. So we probably need to do this after render has happened the first time. So if we come down here and just do it right here, I wonder if that will work. Let's find out. So we're gonna... Oh, wait. No, I think that's not actually the issue. It's that I'm using panel. I need to use panel.element. Let's see if that works. I see some things. I see things. Are those things? Let's zoom in. It says hello world, but it's completely backwards. Okay, we probably need to flip that around. But hey, good news. We have a flippin' React application rendering inside of our 3D panels here, which is flippin' sweet. Okay, so we need to change our rotation a little bit. Wait, do I just need to make that negative? I think I just need to make that negative. Let's see, does that work? Ish. So then if we flip these left panel and right panel, no, that's not right. That doesn't do it. Which, you know, it makes sense that it doesn't do it. Let's be real. Okay, so panel rotation is 40, and we need to spin that guy around. So, all right, left panel, generate left panel. Our rotation is negative this dot panel rotation, so it's currently negative 40. Okay, so let's just do some math. If we've got negative 40, then we need to go another 180 degrees. So like 200 and something, 220. Alternatively, we could do what I did over here and stick in a slider and, and figure it out that way, which sounds way easier to me. So let's just do that. I'm not even going to bother with a label for it. We're just going to shove it in there and see what happens. Boop. There we go. We got a rotation. The value is negative 40. And then we need a event listener to listen for it. Just gonna grab this guy and copy it over into our bind events. See, isn't it nice having bind events here? It's just, it makes me happy. Okay, input event, we don't actually need that. Let's just get rid of it to avoid assignment. Native this dot panel rotation. Does that work now? No, not yet. Let's see, what am I missing? This dot panel rotation. Oh, right, because panel rotation pulled from the thing. So we're going to say panel rotation equal event.target, which is going to be, so if you're only used to working with jQuery, the add event listener is probably a really weird syntax to you, but it shouldn't be, because it's essentially jQuery.on or jQuery selector.on, right? And you choose the event that you want to listen to, and then you pass in a function that reacts to it. The function receives the event, and we can act on things that way. The value in doing .on from jQuery is there's actually quite a bit of value. One of them is that .off is way easier to use than remove event listener, where you have to pass in the event type, but you also have to pass in the exact same function for it to work. So you can't just use anonymous functions, which sucks a lot. But anyways, we're gonna get event.target.value and panel rotation. All right, now if we change this, it should do things. It's still doing nothing. It hates me. Okay, ID rotation starts out at -40, and so we're just gonna console.log rotating question mark console. All right, let's see. Does it rotate? It's rotating. It's definitely rotating. It's just not actually affecting. Oh, so we've got this left panel. That's right. Okay. How do we want to do that? Let's go down to scene. QRS scene. Great. Console.log. If I can console.oog, I should just alias that. All right. This _scene. Okay, great. And so that will log out scene for us. Sweet. And now we can check the scene to see, I think it has a children. Yep, there we go. And each one is a thing. So this would be our left, our first one is our left panel. Great. So we'll just work with that. Here we'll say this dot scene. Oh, I can't spell for anything. Dot children. And then we'll do 0 and 1. That should work. Hey, we're spinning. Whoa, we are spinning like a lot. Let's see. Rotation. Why don't we just say 40 and then, I mean, min, max. Ugh. Yeah, let's just leave it there for now and see. So that's closer to what we want, right? Let's say document.query selector. I want to get the value from that slider just to see what the actual, what we've just set it to, basically. So I'm going to use the Codepen console. Whoa. Okay. Oh, there's a lot of logging happening. I should really fix that. Oh, that's in the scene. That's right. Let's just jump down here. We'll find it. Don't want that anymore. Okay. That should make this a little easier. There we go. So we want to get the dot value. It's 40. What? Oh, crap. All right. So we need to do, there we go. That's about right. Let's try again. 43? It seems so like, what? Okay, we'll try 43, I guess. Just see what happens. Okay, defaults to 43. Hey, look at there. That's pretty darn close. Now here's the thing, though. If I use rotation over here, it's way more gentle. Like way more gentle. Whereas if I use it over here, it's like really, really jerky. And I'm not sure. Oh, I do know why that is. It's because in the rotation on this one, Panel rotation, we actually divide the value by 100 because it's easier to do that than it is to yeah, okay, everything makes more sense now. It's easier to do that than to set the steps as like 0.1 in your range slider, because then things get real weird with the slider, especially if you want to add tick marks. So what we need to do is, I was actually right originally in that this needs to be positive and this needs to be negative. But because I wasn't doing my division, things were going like, you know, a value of 40 was actually a value of like 4,000 degrees, which is so completely unnecessary. So anyways, we'll flip those values, and here we are back to where we want to be. Everything is super flippin' magical. So we can get rid of this guy now because we don't need it anymore. Our rotation slider we don't need. Delete that. Great. And now here we are. Again, we have a React app rendering in our thing. So let's go a little farther. Right now we've just got hello world. Why don't we do a div to contain this stuff? Ugh, I hate having so many unnecessary divs, but you know, whatever. For now it's fine. We'll deal with it more later. And then we're going to do an ordered list. And let's say list items. And then up here we'll generate a bunch of random list items. So let list items equal an array. And then we'll say while we'll say let I equal 0, index equals 0, and then while index is less than 100, we will generate some crap and update the index. Oh no, don't, oh, I just broke everything. Now it's probably stuck in an infinite while loop because I didn't have the index plus plus in there yet. Oh no. Why did I do something so dumb? I mean, like, so dumb. Okay, let's see if I can fix this without having to no, I'm gonna have to close the tab. Oh, I really hope I don't lose anything. That sucks. Alright, Codepen. Just bring this up back over here and close a couple things that I don't need. Alright, what do we got left? Well, just public. It should be in order. Okay, yeah, this is the one. Okay, we lost not much, so that's okay. All right, I'm not too upset. I'm just gonna power through and put this stuff back in real quick. Let list items equal an array, and then while false, we're just gonna force it to not do this at all until we're done. Say index plus plus. All right, let index equal 0. And we'll say list items dot push, and we'll create a list item. What are we gonna do? We'll just say li/li, and then some text, some random text thing, math.random times 100. Yeah, sure, we'll just do math.random. That's fine. Right now it's just a string, so we'll interpolate it. And then let's create our list down here. OL for an ordered list. OL, there we go. We'll say list items. Oh, I put too many curly brackets on there. There we go. All right, so now it's empty. There shouldn't be any list items. If I set this to index is less than 10, just say 10 items, we should get, yeah, look at that. Look at that magicalness. We have a list for a React app running inside of a panel that is part of a 3D framework. This is awesome. I'm pretty stoked that it was so simple. Yeah. Okay, so I am pretty much going to call the live stream for now because I need a break and some water and stuff. But either tomorrow or Friday, I think I will come